Good evening, students.
Yes, sir.
Good evening, sir.
Okay. So, shall we do the problems of chemical equilibrium? Then we'll go for the hydrocarbons introduction. Okay.
Yes, sir.
Things aromatic hydrocarbons, directly affect. Oh my God. Okay. Yesterday we were discussed about the chemical equilibrium. So lastly, I started the solubility product. Now I will tell you what is solubility product. Then we'll go for the problems. Okay, what is solubility product? What it means, ma? Solubility product means. So some of the solid which are highly soluble in the some of the salt which is soluble in water, it's completely soluble, whereas some salt is not completely soluble in water, but it partly dissolved in water and then remaining will be become undissociated. So for that salt is called as sparingly soluble salt. So all the substance which will have the solubility in a particular solvent at particular temperature. When you are increasing the solubility, when you are increasing the temperature of the solution, the solubility of the salt also will increases. So generally, how we can say the solubility of the solute, solubility of the solute, so that will be in the moles per liter. That's equal to solubility of solute in gram per liter divided by molecular weight of the solute. So this is the way we can find out the solubility of the solute. So the solubility of the sparingly soluble salt and acids base, we have many things. Mostly the salt which contain carbonate, phosphate, fluoride, acetate are soluble at low pH. When the salt of weak base dissolve at a higher pH. So when you take the calcium fluoride, which is insoluble in water, but it goes into the solution when some acid is added. So it will be there. So how you can decide that solubility of the product? So this common ion effect and combined with the solubility of the ionic solvent only, it will precipitate the our salts and all. இப்போ நம்ம salt analysis school பண்றீங்க. So even the solution which contain ion, some of the ions only get precipitated. Okay. So this precipitation, because of their ionic product value is lesser than your solubility product. That is why it get precipitated. Okay. So how we can say now? When you have AB is a sparingly soluble salt. When the sparingly soluble salt you are having, you are put it in the water, it become undissociated or unionized. But some part of the solute, it get ionized into A plus and then B minus. So they are in the ions at saturated solution. So how can you find out the solubility product value? So the KSP, constant of KSP become, when you have that A plus B minus no, so A plus ion, how many moles? And then B plus ions, how many moles? B minus ions, it's how many moles? That only will decide. So when you have X, A and Y, B salt, when it ionize, it gives A moles of X A plus இந்த மாதிரி வேண்டாம் easy methods. When you are having the salt, you have AgCl, simplest example. When you have the AgCl, when you put it in the water, it becomes Ag plus and then Cl minus. Okay, so the solubility product of AgCl become the constant of Ag plus and then constant of Cl minus. So if you are taking one mole, S moles of this and S moles of this, then it become S into S. So that become S square. So the solubility product AX type salt, okay, or AB type salt. AB type salt means the solubility product KSP become S square. So the solubility is equal to root of KSP. So suppose if you are having salt like AB2, example, lead chloride, calcium chloride, sodium sulfate, and lead nitrate, like this salt, then the solubility product become KSP is equal to, so Pb2 plus, correct, into 2Cl minus. So if you are taken S moles of it will produce S moles of this and S moles of this means S, correct, 2S. அப்ப என்ன ஆகும்? இப்படி வேல்யூ என்ன ஆகும்? ஒரே நிமிஷம். Two S square because 2Cl no, so 2S square. The Pb2 plus it become -1, that's why S into 4S square, so it become 4S cube. So like that it will come. So when you have that salt type AB3 or A3B, then KSP become 27S4. Same way, when you have the salt become A3B2 and A2B3, so the KSP become 108 and S power 5. S is nothing but your salt. So it's Al2SO4 thrice example and Ba3 barium phosphate twice. So for this AlCl3, FeCl3 and sodium phosphate. These are the example for the solubility of product. Now we will work it out the problems. First NCERT la irukradha solve pannalama. Shall we do that?
Okay, sir.
So what is the Kc of the following? Second question. What is the Kc of the following equilibrium when the equilibrium concentration of substance? The SO2 concentration that's equal to 0.6 molar and O2 concentration that becomes equal to 0.82 molar and SO3 concentration become 1.90 molar. Then what is the Kc equilibrium constant? So how can you establish the equilibrium? SO2 plus O2 it gives SO3. When you have to equate, totally 4 oxygen is there. So when you are introducing 2 over here, then it becomes 2 SO3. So for that, Kc is equal to, what is that? SO3 power 2 divided by SO2 power 2 and then O2. So you substitute the value 1.90 moles square divided by 0.60 moles square and then 0.82 moles. Now you answer me that question. So meter moles cancel out. Correct? Then what will be the answer? What will be the answer?
Sir,
Ah.
how is oxygen balanced in this equation, sir?
Yes, it was balanced. No, 2 2s are 4, 4 plus 2 6 oxygen, 2 3s are 6,
Oh,
6
okay,
oxygen.
sir. Okay, sir. Okay, sir.
So now you tell me what is the value to find out. So 1.90 into 1.90 into mole square divided by 0.6 into 0.6 mole square into 0.2 moles. So capital M means moles per liter. இதுதான் capital M ங்கிறது. So 1.9 1.9 cancel out பண்ணி சொல்லுங்க. What is the answer? What you are getting? What is the value you are getting? Are you doing the calculation?
So 1 minute. Sir, 2.96, sir.
How much value you are getting?
Sir, I think 2.96, sir.
2.96. Hello, 1.9 into 1.9. 1.9 into 1.9 that divided 0.6 into 0.6 into 0.82. That value become 12.2289 and M power minus 1. So m is moles per liter. Then it become 12.229 because 8 9 I'm changing to 9. Okay, 2 to 9 liter per moles. Okay, this is how you have to do this problem. And the next problem, at certain temperature, the total pressure of third problem 10 power 5 Pa. So the iodine vapor contain 40% by volume of iodine atom. So I2 gas, it gives 2I gas. Calculate the Kp for the equilibrium. So first partial pressure they are given no. So what is the partial pressure? So partial pressure of iodine atoms P1 is equal to, so what percentage? 40 percentage, 40 divided by 100 into total pressure எவ்வளவு இருக்கு 10 power 5. So when it tends, then it become 10 power 4. It become 4 into 10 power 4 Pa partial pressure. Otherwise 0.4 into 10 power 5 Pa. இப்படி வச்சுக்கலாம். Okay, so the I2, the partial pressure of I2 become எவ்வளவு இருக்கும் 40% of I2 vapors போது remaining 60%. So 60 by 100 into 10 power 5, it gives 0.6 into 10 power 5 Pa. So that Kp is equal to partial pressure of iodine twice divided by Pi2. So இதான ஈக்லிபிரியத்துல இருக்கு 2I தானே இருக்கு. So 2I ன்னு சொல்லும் போது it become Pi become 0.4 in 10 power 5 square 10 power 5 square divided by 0.6 in 10 power 5. So it become 10 power minus 5 போயிடுமா அப்போ 0.4 in 10 power 5 divided by 0.6. So how can you write when you are dividing? What will be the answer? So 0.2 and 0.3. 0.2 by 0.3. What is the value? 0.2 divided 0.3. It become point. Oh, hello. 0.4 into 0.4 is there, no? Another 0.4. So 0.8 divided by 0.6. 0.8 divided by 0.3. It become 2.66 in 10 power 4 Pa, because the value it gives 0.266 and 2.66 in the 10 power 4 Pa. So next, write the expression for the equilibrium constant Kc of the following reactions. You have many reaction given, no? For the fourth reaction, you tell me Fe3 plus 3OH minus for the reaction 4, fourth question, adala fourth option Fe3 plus 3OH minus equilibrium with FeOH thrice. You tell me what is the Kc value? Kc, how to write the Kc? So they are given solid also, solid, aqueous. When you are writing that, what is the Kc value? How will you write? Each person has to answer one. Yes. Yes. Kc ன்னும் போது Kc is equal to product divided by reactant. So according to that, you answer that. The Kc is equal to, I will do one thing. I will call one by one, then you will answer. That would be fine. நீங்க சீக்கிரமா ஆன்சர் பண்ணீங்கன்னா நம்ம அடுத்த போர்ஷன் போக முடியும். இல்லைன்னா இதே போர்ஷன்ல உட்கார்ந்துட்டு இருக்க வேண்டியதுதான். K6 சொல்லுங்க, you try your own. You try your own. Only 3 persons. Abhinav, you tell me the Kc value. So what is the product, ma? What is the product?
Sir,
Constant.
FeOH.
FeOH thrice divided by Fe 3 plus and OH minus thrice. So when we have the solid become the value is 1. Am I right? So the Kc is equal to 1 by Fe 3 plus concentration aqueous into OH minus concentration power thrice. This is the case. So same way, equation 2. Equation 2. What is the equation? 2 copper nitrate solid. It gives 2 copper oxide solid and 4 NO2 gas plus O2 gas. When it is the solid form, that consider as a one unity, the concentration. First, when you are writing Kc, CuO concentration square, and then NO2 gas concentration power 4 and O2 gas. So this is how you can write, divided by concentration of copper nitrate power 2. So you can leave these two because they are in the solid state. When it is in the solid state, you can leave that. The remaining will be NO2 power 4 and O2. Okay. Okay. So you tell me the last one, fifth one. I2 plus 5F2 and 2IF5. So I am not mentioning any solid, liquid, gas. Then you have to take all those things. So one thing I am reporting, this is a solid. Remaining I am not mentioning. Then how will you write the Kc value? How will you write the Kc value? How will you write the Kc value?
Sir, IFI power 2 by F2 power 5, sir.
By?
F2 power 5, sir.
Very good. So that is the Kc value. The next question. Find the Kc value for the following equilibrium. The value from the value of Kp. So what is the relationship between Kp and Kc? So when you have the Kp value, Kc you can calculate it. So Kp is equal to Kc into RT power delta Ng. So this is the equation. Okay. So when they are given 2 NOCl at equilibrium, it becomes 2 NO and Cl2 gas. So the Kp value is 1.8 in 10 power minus 2 at 500 degree. 500 Kelvin. At 500 Kelvin. So when you are answering for this question, you can find out delta Ng. Delta Ng is equal to product minus reactant. Product mother 2 moles and in 1 moles, this is 2 moles. So 2 plus 1 minus 2, it become 1. So delta Ng become 1. Then Kp is equal to Kc into RT power 1. So Kp is equal to Kc into RT. So when you have 1.8 in 10 power minus 2, that become Kc into. So what is the value of R? So R is equal to 0.0831 bar liter mole power minus 1 per Kelvin, or 8.314 joules also you can put. For this calculation, the R value you have to write like this. So Kc into 0.0831 into temperature become 500. So the Kc value, Kc is equal to 1.8 in 10 power minus 2 that divided by 0.0831 into 5. When you are simplifying, you will get that is the Kc. And the second equation, when you have the calcium carbonate, so it gives calcium oxide plus carbon dioxide. This is solid, this is solid, this is gas. So the Kp value is 167 at 1073 Kelvin. So delta Ng value உனக்கு தெரியும். இப்போ இது ஒரு மோல் எடுத்துனா 1 so 2 இது சாலிட்ன்றதை இதையும் விட்டுடலாம். அப்போ டெல்டா Ng is equal to 1. அப்போ Kp is equal to Kc into Kc is equal to Kp is equal to Kc into RT power 1. So the Kc is equal to Kp by RT. Kp value is 167 that divided by 0.0831 into 1073. So when you are having that value is known as your Kc value. Okay. Is it clear?
Yes, sir.
Next question. So for the reaction NO gas, when it combined with ozone, it gives NO2 plus O2 gas. Now the Kc of the reaction, Kc of the so for the following equilibrium, Kc is equal to 6.3 in 10 power 14 at 1000 Kelvin. Both the forward and the backward reaction in the equilibrium are elementary bimolecular reaction. What is the Kc for the reverse reaction? So how will you find out? Because forward reaction bimolecular, backward reaction bimolecular, ரெண்டு molecules தான் involve ஆகுது. Okay, so the Kc is equal to Kf by Kb தானே போடுறோம். Now so the Kc value is always the Kc equilibrium constant is inversely proportional to your backward reaction, and Kc is directly proportional to your forward reaction. So according to that, when you are writing, so the Kc dash, that means reverse reaction. Reverse reaction, that would be 1 by Kc. So according to that, 1 by 6.3 in 10 power 14. So the value is reverse reaction. அவ்வளவுதான். So another question. Why pure liquids and solids can be ignored while writing the equilibrium constant? Yeah. So the reason behind that, when you take pure liquid and
So the molar concentration is constant, sir.
that molar concentration is constant. So as the density of pure liquid or pure solid is constant at constant temperature. Okay, and their molecular mass also constant. So therefore the molar concentration are constant. That is why you cannot include in the equilibrium constant. So that means for the pure liquid or pure solids equal to number of moles divided by volumes in liter. That's equal to number of moles na enadhu mass, how much weight you are taken divided by molecular mass divided by volume. எவ்வளவு volume எடுக்கிறோம். So mass by volume into 1 by molecular mass. So mass by volume density is equal to mass by volume. So that's equal to density divided by molecular mass. So when you are taking the pure liquid, so density will not be changed and molecular mass will not be changed. That's why we consider it as a unity. Otherwise, we are ignoring in the reactions. Okay, clear? Is it clear?
Yes, sir.
So இன்னொரு class வந்துட்டு நம்ம இந்த problem discuss பண்ணலாம். Now we'll go to the hydrocarbons. I will introduce. Today I will introduce. Next class it will be easier for me. So I will send it a handwritten notes to your group. Bhaskar sir will send you.
Okay, sir.
So we are going to write the hydrocarbons. So the name itself, it gives an idea that you have carbon and hydrogen. So in this, you are only having carbon and hydrogen. So the hydrocarbons, which will contain the compounds of carbon and hydrogen. We have n number of hydrocarbons. Okay, but these elements readily undergo combustion. When it combusts or when it were burning this, it will give carbon dioxide, and because of that, it readily undergo combustion. It can be used as a fuels for many cases. For example, LPG, liquefied petroleum gas, what we are used in our home is LPG, that is made up of hydrocarbon, and CNG, compressed natural gas, and then liquefied natural gas. All are we are using in for the fuel purpose. Okay. So we have to know about that hydrocarbons. So how we are classifying the hydrocarbons? So we can classification. First, classification of hydrocarbons. When you are classifying this hydrocarbon HC, you can classify two types first. One become acyclic or open chain compound. Okay, and then it become cyclic hydrocarbons. So these are the compound which will be open chain of carbon atom in their molecules. So now you are again it will be classified in two types, become saturated open chain compound and unsaturated open chain hydrocarbon. So these are the compound which will contain carbon-carbon single bond. So otherwise it will be alkanes, which has the molecular formula, general formula CnH2n plus 2. The name, it should be N with ANE. The N value you can start with 1. And then unsaturated, again we are classifying in two types. When the carbon-carbon contain double bond or carbon-carbon will contain triple bond. Saturation, unsaturation based on the bonds we are telling here. Okay, and the carbon-carbon saturation is double bond means it is called alkenes. So it has the general formula of CnH2n. The name should end with ENE. The N value started with 2. So another unsaturated open chain compound is alkynes. It has the general formula of CnH2n minus 2. It ends with YnE. The n value is started from 2. So it is a homologous series. It is also homologous series. It is also homologous series because the continuous 2 atom will vary with the CH2. That's why we are telling that homologous series. So this is the way by which you can classify the open chain compounds. And then we are classifying cyclic hydrocarbon. These are the hydrocarbon which will contain closed ring. Okay, then it become alicyclic or aromatic. What is the meaning of alicyclic? So the hydrocarbons having the ring which will have only the single bonds. So it will have the properties are similar to hydrocarbons. So when you take cyclopentane, cyclopropane, cyclobutane, cyclopentane, cyclohexane, okay, cyclic form, and then cycloheptane, 7 carbons, and actenes, sorry, cyclopropane, cyclobutane, cyclopentane, cyclohexane, and cycloheptane, and then cyclooctane. So these are the types of compound. And then aromatic compound. These are the hydrocarbon which contain fused ring or isolated benzene ring. So these are called aromatic hydrocarbons. The examples are benzene, naphthalene, anthracene, phenanthracene. So these are the aromatic hydrocarbon. Then toluene, xylene. It will come, it goes like that. So it will contain only carbon and hydrogen. Okay. So this is the way by which you can classify the hydrocarbons. Okay. In our study, we are going to study about the alkane, alkene, alkynes, and then aromatic hydrocarbons. First, the naming will be same for all the case. Only the name should end with ANE, ENE, YNE. Okay. Here we are going to study about the Markovnikov rule and their mechanism, and then aromatic hydrocarbons and their importance, and then resonance. Those things we are going to study. I think here it doesn't have that hybridization இருக்குப்பா இந்த lessonல. Do you have hybridization of methane, ethane, and ethylene? Once again, I will check with your NCERT book. One minute. Nomenclature, hydrocarbons, primary, secondary, no. Oh, no. Oh, this feels like alkynes, சரி. Okay. Okay, now we'll go to alkanes. So what is alkanes? It has the general formula CN H2N plus 2. The name should end with ANE. It will contain carbon-carbon single bond and the N value started with 1. Okay. When the N value started with 1, it has CH in our row. CH, you substitute 1 over here. CH, CH, what is the value you will get ma? CH, the formula substitute பண்ணுங்க. CH, CH,
Force.
4. Then it will be 1 carbon. Then the name should come methane. And the N value is 2. It become C
H6. Sir.
H6. So you can write CH3 hyphen CH3. You have 2 carbon. That's why E name should end with A and E, ethane. So I am writing the IUPAC name. These are the IUPAC name. Okay. And N is equal to 3. It become C3H8. So you can write CH3, CH2, CH3. It become propane. The common name is N-propane. So N avasila next one. N is equal to 4. It become C4H10. So CH3, CH2, CH2, CH3. So 4 carbon is there. That is why butane, or the common name is N-butane. N-butane. Now the same thing I can write CH3, CH, CH3, CH3. So it has the same 1, 2, 3, 4 carbon, 3, 6, 9, 10 nitrogen, same as like your butane. So this is called, you have to name the compound 1, 2, 3 or 1, 2, 3. So you have to choose the longest chain and it should have the nearest number, and the branching according to your alphabet only you have to give the prefix of the branching. So this is the IUPAC rule. You already know that. When you have this second portion, you have the methyl. So it becomes 2 methyl. Remaining how many carbon? 3 carbon. Propane. The common name is isobutane. Iso means branching meaning. Okay. And then N is equal to 5. C5H12. So CH3, CH2, 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 CH3. 1, 2, 3, 4, 5. It becomes pentane. This is called N-pentane. Why it is called N-pentane? It goes like chain. No, that is why it's N-pentane. So the N-pentane, it has the remaining form CH3, CH2, CH, CH3, and CH3. So same way you have to name this 1, 2, 3, 4, 1, 2, 3, 4. So the bottom number you have to take because the nearest branching is 2. That's why we are taking lower number. Then it becomes the second portion. I have the methyl group, another 2 methyl. Okay. Remaining how many carbon is there? 4 carbon is there. 2 methyl butane. This name is isopentane. Suppose the same compound I could write CH3C, CH3, CH3, CH3. Now you also you are counting, it will get C5H12. So when you are branching 1, 2, 3, 1, 2, 3. So one and the same. So second portion you have the 2 methyl group. When you are naming this 2, 2 because the methyl group 2 is there. 2, 2 dimethyl. Remaining how many carbon? 3 carbon. Propane. The common name is neopentane. Okay, is it clear? This is how we have to give the name. Now you tell me, I will write one structure. Now you tell me the naming. IUPAC name. How will you IUPAC? Name it. Hmm.
2,3 ethyl pentane, sir.
2,
3 ethyl pentane.
2,3 diethyl pentane. Ah? So
Ethyl
yours
pentane, sir.
1, 2, 3, 4, 5. Correct? This is how you named, no? 2,3 diethyl pentane. So now I'm telling the name is wrong. I'm giving the name 1, 2, 3, 4, 5, 6. Okay. So when it come over here, otherwise 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. When you are giving name by green or by black you are getting the third and fourth position substituted. By the green you are getting third and fourth position substituted. So you can take any of this, that doesn't matter. Okay. Whereas here the 6 carbon, whereas he has chosen only 5 carbon. So you have to choose a longest chain. So when you are choosing, it become, you have one methyl group and another ethyl group. So methyl group comes M, ethyl group comes alphabet E. So E only should come first. So 4 ethyl, comma 3 methyl hexane. This is the name. புரியுதாப்பா? நீங்க என்ன தப்பு பண்ணீங்கன்னு புரியுதா? Is it clear?
Yes, sir.
Okay. When you have the hexane, we can have the, what are the possible structures? So what is the formula for n is equal to 6? C6H14, right? CnH2n plus 2 formula prakaram potumna 6 12s are 6 2s are 12, 12 plus 2 14. 14 vandadna. So you can write CH3, CH2, 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 CH3. This is called N-hexane or hexane. The name is called hexane. And the other name, other structures you can write CH3, CH2, CH2, CH, CH3 and CH3. So when you are IUPAC name it, I will write the possible structure and all. CH3, CH2, CH, CH2, CH3 and CH3. This one. CH3, CH, CH3, CH, CH3, 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 C, CH3, CH3, CH2, CH3. நாலு ஆறு. அதேதான் வரும். Now you tell me the IUPAC name for this compound. For this, what is the IUPAC name? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Which number you have to choose? Which number you have to choose? Which number you have to choose? Which one you have to choose, ma? Which number you have to choose?
Two, sir.
Hmm.
Two, sir.
See, you have to give the number, correct? You have to choose a longest chain. So when you are choosing longest chain, you can give two-way the number in upper side and lower side. When you are given, so the branching will come under the lower value. So the numbering should be bottom one is correct. Okay, this one is correct. So according to that, second portion you have the methyl. So remaining 5 is their carbon, then it become pentane is the root word. So then you are giving 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So according to that, both the numbering is correct because third portion only you have the group. So 3-methyl pentane is the name. Okay. So for this 1, 2, 3, 4. 1, 2, 3, 4. Both the numbering is correct. And then second and third carbon having methyl groups 2, 3 dimethyl butane.
Butane.
For this 1, 2, 3, 4. 1, 2, 3, 4. So above number is correct because above number only having second
Got it,
carbon having
sir.
two groups. So 2, 2 dimethyl butane. Okay. So
Okay,
this is
sir.
how we have to name that compound. Okay.
Okay, sir. Yes, sir. Understood, sir.
Now this compound will exhibit the isomerism. Okay. So the physical, when we are coming to the physical property, we come to know that. Now we'll see the preparation of the compound. So preparation of alkanes. From unsaturated compound or hydrogenation, you can prepare. When you have the compound like CH2 double bond CH2 ethylene, when you are adding hydrogen in the presence of Raney nickel. Raney nickel is nothing but nickel aluminum alloy. When you are putting sodium hydroxide, aluminum will be removed. You have the nickel as a catalyst. This nickel in the presence of hydrogen, it can be added over here. It gives CH3, CH3. So by this way, otherwise you can have alkynes. So ethylene treated with hydrogen and nickel, it become ethane. Acetylene in presence of hydrogen, it also give the alkanes, ethanes. So this way you can do. Another way, the same ethylene, acetylene, you can treat with the hydrogen in the presence of nickel or palladium or platinum. So this is called as hydrogenation. So what they are doing, we are adding 1 moles. This known as addition reaction. Because you are adding all those things. That's why it's addition reaction. So when you are using the catalyst like platinum or palladium, the hydrogenation proceed very easily. When you are using nickel, you have to heat that. Okay, then only reaction will go. So with the Raney nickel, the reaction takes place around 500 and above 500 Kelvin. Okay, so the Raney nickel is the alloy of equal amount of nickel and aluminum. When you are treated with the sodium, aluminum will be leached out. So you can have that by this method. So methane cannot be prepared by this method because it has only one carbon, right? So methane cannot be prepared by this method. Okay, so when you want to prepare the methane, so you have to do that. So second method from alkyl halide. So alkyl halide means RX. When you have RX, if you have suitable reductant, then you can have the alkane plus HX. So what are the reductant we can use? So we can use zinc copper coupled in ethanol, E2OH means ethanol, and sodium ethanol, and then zinc HCl, zinc acetic acid, platinum or palladium or nickel hydrogen or aluminum mercury alloy with the ethanol or lithium aluminum hydride. Anything you have taken, you will get that. For example, you have CH3, CH2I. When you are treated with lithium aluminum hydride, you take that, it will give CH3, CH3 plus LiCl. Same way, when you are treated with methyl iodide with zinc copper coupled, it will give methane plus hydrogen iodide. By this way, you can prepare. Okay. So in the next class, we can discuss about all those things. Okay. Now we will wind up with this.
Thank you, sir.